Hello my dear students, I hope you are doing great. So now let's get started with another elegant question from Pathfinder. Problem number 21 from Kinematics. Okay, the problem says that a marble is projected in a viscous fluid with an initial speed u at an angle theta above the horizontal. Drag force of the fluid results in an acceleration AD vector is equal to minus kv vector in addition to that of gravity, where k is a positive constant and v vector is the velocity of the marble. Okay, so this is basically a projectile, and here a drag force is also there. So we can say that in this projectile, the acceleration is not remaining constant throughout the motion. Okay, so during the motion, if I say that at time t, if v is the velocity of the marble here, if v is this velocity of the marble, then in that case acceleration due to gravity will be g downward. This is one acceleration, and another acceleration AD vector. Drag force of the fluid results in an acceleration AD vector. So AD vector is equal to minus kv vector. So its magnitude is k times the speed, and its direction is opposite to the velocity vector, which is in this direction. It is in opposite direction, in this direction. So this is your kv, is the acceleration due to this drag force of the fluid. This is the situation, and the initial speed is given to be u. So this is the initial speed u, and angle is theta here. Now we have to find the position coordinates like x comma y. X comma y we have to find. So at this point P, we have the position coordinate x comma y, as well as the x horizontal and the vertical components of velocity of the marble as a function of time. So we need to find x, y, vx, x component of the velocity and y component of the velocity, and also we need to find the terminal velocity. So 5 things we need to find. So let's see how we can solve this problem. So one of the approaches which appears in our mind is like resolving the acceleration vector along x and y, okay, as a function of time, right? Or we can resolve the acceleration along the radial and the tangential direction. But if you resolve the acceleration along the radial and tangential direction, then it won't lead to anything. So we will have to resolve this in x and y direction only. Let's see how we can do that. And the beautiful concept is here also. Let's say that this angle is alpha, this angle is alpha. So in that case, along x direction, the acceleration vector is going to be equal to dvx over dt. dvx over dt is the acceleration along x, and which is equal to the resultant of these two accelerations, right? The acceleration due to gravity and acceleration due to this drag force of the fluid. So here we can say that this angle is alpha, so this angle is also alpha, okay, vertically opposite angle. So now dvx over dt along horizontal direction, the acceleration will be only the component of kv, which is kv cosine of alpha with a negative sign. Why negative sign? Because dvx over dt is along x direction, and kv cos alpha will be in this direction along negative x. So this is our one equation. Okay. Similarly, let's write down the another equation along y direction, which is dvy over dt is equal to how much? dvy over dt is in vertically upward direction, so it is equal to negative of, so g plus kv sine alpha, g plus kv sine alpha. This is dvy over dt. This is the second equation. So only 2 equations we have, and now we have to find xy, vx, vy. Let's see how we can do that. See here, alpha is variable, right? And we also cannot write u cosine theta is equal to v cosine alpha, because here acceleration g is not constant, because we have another acceleration also. So that equation of projectile will not work. So how we can do that? Look at the first equation. So what appeared in my mind was the projection method. How we can apply the projection method? Look at this. dvx over dt is equal to negative k, and for v, what is v? V is the speed, right, which is rate of change of the distance. So here v is ds, which is elementary distance, ds over dt times cosine of alpha. Basically my objective is to get rid of alpha, which is unknown and which is variable also throughout the motion. So now we can observe that we can get rid of dt also. And now what is ds cosine alpha? We can observe this. What is ds cosine alpha? Basically ds is this distance, elementary distance, and this elementary distance, I'm drawing it here, is ds, and alpha is this one, this angle. So what is ds cosine alpha? Obviously ds cosine alpha will be dx, right? Dx, right? Because if we draw this in right angle triangle, this is going to be the projection. ds cosine alpha is going to be the projection along x direction. So this is basically dx, okay? Along x direction, this is the projection. So what we can write here is dvx is equal to negative k, and in place of ds cosine alpha we can write dx. So now we can observe it here that we got rid of alpha as well as time. dt also got cancelled. So now what we can do here is, again we can integrate it, right? So if you integrate it, k is constant, comes out of integration. So initially x is equal to 0. The marble is here at the origin. So from x is equal to 0, and at x is equal to 0, what is vx? Vx is u cosine theta, right? Which is, I'm writing ux here. So ux to vx, which is the x component of velocity at any time t, at this position at time t. So now we can write this one as vx minus ux is equal to minus k, and from 0 to x, so it becomes minus kx. So you can say that ux is constant, ux is u cosine theta, so vx is your dx over dt, right? So this is your dx over dt is equal to, I'm writing ux only, ux minus kx. Okay, now this is a linear differential equation. We are already familiar with this one. Dy by dx plus dy is equal to q, this type of equation. Or you can directly integrate like this, dx over ux minus kx is equal to dt integral. And if you integrate it from 0 to t and from x is equal to 0 to x, and this is, by the way, also this kind of equation we have already encountered in RC circuit also. So if you integrate it, you will be getting like this, okay, minus 1 over k times ln of kx minus ux over ux is equal to time t. And further, if you simplify it, you will be getting x as a function of time, which is kx minus ux is equal to e to the power negative kt. And by the way, this is your mod. It becomes ux minus kx if you open this mod, and this is equal to e to the power minus kt. So x comes out to be equal to this also, e to the power ux times, this is ux times e to the power negative kt. Okay, now it becomes x is equal to ux times 1 minus e to the power minus kt over k. Okay, this is x as a function of time, where we have ux is equal to how much? U cosine of theta. And by the way, dx over dt is what? Is, if you just differentiate this x as a function of time, you will be getting dx over dt. So dx over dt is vx is equal to, if you differentiate it, you will be getting ux over k as k e to the power negative kt, which comes out to be ux times k gets cancelled, e to the power minus kt. That is the x component of the velocity as a function of time. So we got x, we got vx. Okay, so now our objective is to find y and vy. So in order to find y and vy, we will look at equation number 2. So now let's work out equation number 2. In the similar fashion, we worked out this equation using the projection method times So here I'm writing like this, dvy over dt. So now multiply it with dt both sides, so it becomes minus g dt plus k v, and in place of v I'm writing rate of change of distance ds, elementary distance, times sine alpha times, okay, times dt, and dt gets cancelled by the way. So our equation looks like this, dvy is equal to minus g dt plus k times ds sine alpha. And now in the similar fashion, like here we wrote ds cosine alpha as dx, and this in a similar fashion ds sine alpha will be the y projection, right, along the projection along the y axis. So you can write ds sine alpha as k times dy. Okay, now we got rid of alpha. Now we can integrate it. So g gets out of integration, k dy. So vy from uy, which is u sine theta, uy is u sine theta, I'm writing it here. So ui to vy, negative g 0 to t, and dy integration from 0, y is equal to 0, it's at the origin, to y. So we will have this equation at vy minus ui is equal to negative gt plus ky, okay, plus ky. Okay, so negative is also out of the bracket. So basically this is out of the bracket. So now how will we solve this for y? Look at this. vy is what? Is your dy over dt. I am taking ky to the left side, so it becomes plus ky, okay, and now I am taking ui to the right side, then it becomes uy minus zt. So why I am doing this one? Because we are familiar with this first order linear differential equation, dy by dx plus py is equal to q. This type of equation we are familiar with. Now we can easily solve this equation. So here dy by dt plus ky is equal to, this plays the role of the function p and this plays the role of function q. So we have the integrating factor, so if is equal to e to the power integral p dx, right? So here in this case e to the power kt. You know the solution of this first order linear differential equation, it becomes y times the if, which is e to the power kt, is equal to integral if, which is e to the power kt, times the q, which is uy minus gt dt. This is the solution for the first order linear differential equation. Furthermore, if we integrate this one, we will be getting times e to the power kt dt integral, which becomes ui over k e to the power kt g t e to the power kt dt integral. So here that is you can say that integral uv dx. So two functions are there, integration by parts you have to apply, then it becomes ui by k my e to the power kt minus g. So this is the first order linear equation solution, and also here you have to have the lambda, which is the integration constant, okay. And now we can find the integration constant from the constraint, as at t is equal to 0 we have y is equal to 0. So we have the value of lambda as your negative uy over k plus g over k square. So now if we plug the value of lambda in this equation, okay, so we will have the final solution. So that's the value of the y, which is finally equal to, that is our final value of y as a function of time. You see, we got finally y as a function of time. So we needed to find out vy also. So how we can find vy? So basically vy is your dy by dt. So if you differentiate it, you will be getting, this is your velocity y, Vy, as a function of time. This is your Vy as a function of time. Now we found these four things: x, y, Vy, and Vx. One more thing needs to be found, which is terminal velocity. How we can find terminal velocity? Very, very simple. See, terminal velocity means when its velocity becomes constant, it means its acceleration is going to be 0. When a vector is 0, then in that case we find the terminal velocity. And in order to have the a vector as 0, it means this term should be 0 and this term should be 0. So this term should be 0, it means cosine of alpha is equal to 0, right? dvx over dt will be 0. And here this term is also 0. G plus k times v, which is speed, sine alpha is equal to 0. See, this equation gives alpha is equal to plus 90 degree or negative 90 degree. V is speed here. Plus 90 means g plus kv. Speed can never be negative. So this cannot be true. Alpha is equal to negative 90 degree. Negative 90 degree means what? So alpha, it means vertically downward direction. This is the value of alpha, which is negative 90 degree. So in that case, we will have g plus k times the terminal speed vt, okay, sine negative 90, which is minus 1, is equal to 0. So we have vt is equal to g upon k. So this is the terminal speed and its direction is in vertically downward. We see that this problem involves a lot of calculation, the first order differential equation we needed to solve, right? And also the beautiful concept which is applied in this question is your projection method. And we applied this projection method, right? Projection method here we applied ds cosine alpha and also as ds sine alpha. Ds sine alpha is ty, ds cosine alpha is tx. So if you have any question, you can comment below. I will be happy to assist you. And I hope you enjoyed this problem. This is a beautiful problem. And in fact, that's what's really a tricky one. Tricky in the sense that projection method was involved. So thank you for watching this video, my dear students. I will be up with another beautiful question. Thank you. See ya. Bye-bye.